You're standing on the outskirts of ancient Babylon around 1750 BCE, where the air shimmers with heat and dust, and spread before you is what looks like an enormous outdoor factory covering several acres along a canal branching from the Euphrates River, where thousands of workers are transforming river mud into the building blocks of one of history's greatest cities, producing bricks at a scale that seems impossible without modern machinery. And yet, every single brick you see, every one of the millions that will form the walls, temples, and ziggurats of Babylon, is being made entirely by hand, using techniques that have already been perfected over 1,000 years and will continue almost unchanged for another 2,000. The brick-making facility stretches as far as you can see, massive pits where workers are digging clay, long rectangular drying fields where thousands of fresh bricks are arranged in perfect rows under the brutal Mesopotamian sun, smoking kilns built into earthen mounds, storage yards where finished bricks are stacked in pyramids 20 feet high, and everywhere the sound of wooden molds slapping against the ground, the splash of water, the rhythmic chanting of work crews who coordinate their movements through song, because making bricks in ancient Babylon isn't just a craft. It's an industrial operation that employs entire neighborhoods and produces materials at a rate that would impress any modern manufacturer if you convert it to bricks per man-hour with hand tools and no mechanical power whatsoever. The process begins about 2 miles away at the river's edge, where specialized workers called clay diggers are extracting the raw material that will become bricks, and they're not taking clay from just anywhere. They're selecting specific locations where the annual flooding of the Euphrates has deposited layers of fine alluvial silt, the result of thousands of miles of river journey that has ground rock into particles so fine they feel like silk between your fingers. And this matters enormously because Mesopotamian clay, unlike the clay in other regions, is almost pure silt with very little sand, which means it shrinks dramatically when it dries. And if you don't understand how to handle this shrinkage, your bricks will crack into useless fragments before they even make it to a wall. The diggers are working in teams of 4, using bronze-bladed tools that look like wide hoes, cutting into clay deposits that were underwater just months ago during the spring floods, and they're digging down about 3 feet to a layer of blue-gray clay that experienced brickmakers know makes the strongest bricks, avoiding the top layer that's contaminated with salt crystals left behind by evaporating water, and avoiding the deeper layers that contain too much organic matter that will rot inside the brick and create weak spots. Each team fills woven baskets with this clay, and here's something that reveals the scale of this operation. A single gang of diggers can extract about 10 tons of clay in a day, which doesn't sound like much until you realize that Babylon employs dozens of these gangs working simultaneously during the dry season, and they need to because the city is consuming bricks at an astonishing rate, somewhere between 20 and 50,000 bricks per day during major construction projects. And every single one starts as river mud in a basket being carried on someone's back from the digging pits to the preparation area. At the preparation yard, the clay is being dumped into massive rectangular pits lined with fired brick to prevent contamination from the ground. And this is where the transformation really begins, because raw clay straight from the riverbank is absolutely useless for brickmaking, too sticky, too elastic, shrinks too much, and will crack the moment you try to dry it. Watch what they're doing now, because this is one of the most critical steps that separates good Babylonian bricks from garbage. They're adding temper, massive quantities of chopped straw that's been brought in from the surrounding agricultural fields. And this isn't random grass, it's barley straw. Specifically because barley straw has the right length, the right flexibility, and the right balance of properties to reinforce clay without making it too coarse to mold. The ratio they're using has been perfected over centuries of trial and error, roughly 1 part straw to 3 parts clay by volume. And workers are mixing this with their feet, sometimes with oxen treading the mixture, breaking down clay lumps, distributing the straw evenly, and adding precise amounts of water to achieve what the Babylonians call good temper, a consistency where the clay is plastic enough to fill a mold completely, but firm enough to hold its shape the moment you lift the mold away. The mixing takes hours, workers rotating in shifts because treading clay is exhausting work, and the master brickmaker is constantly checking the mixture, grabbing handfuls and squeezing them, looking for that perfect balance that he can't describe in words but recognizes instantly through decades of experience. And if the mixture isn't right, if there's too much water or not enough straw or the clay is too lumpy, he orders more mixing, more treading, because everything that happens downstream depends on this mixture being absolutely perfect. The prepared clay is being carried in smaller baskets to the molding stations, and this is where the real production begins, where raw material becomes recognizable bricks at a pace that seems impossible when you realize every single brick is formed individually by hand. Each molding station consists of a flat working surface that's been covered with sand to prevent sticking, a pile of prepared clay within arm's reach, a wooden brick mold that looks deceptively simple but is actually a precision tool shaped with exact internal dimensions, and a bucket of water mixed with fine sand that serves as a release agent. The molder, who is typically a skilled craftsman rather than a common laborer because speed and consistency matter enormously here, is working in a rhythm that looks almost like a dance. Grab a lump of clay weighing exactly enough for one brick, slam it into the mold with tremendous force to eliminate air bubbles and ensure the clay fills every corner. Strike off the excess clay with a straight wooden scraper that leaves the top surface perfectly flat. Flip the mold over onto the sand-covered ground, lift it away with a sharp upward jerk that releases the brick, and return for the next lump of clay. And a skilled molder can complete this sequence in about 15 seconds, producing close to 300 bricks in a working day, and there are dozens of molders working simultaneously in this facility alone. The molds themselves are fascinating because they're not all the same size. Standard bricks for walls measure about 13 by 13 by 6 inches. Bricks for special purposes come in different dimensions. And there are molds for shaped bricks that will form decorative elements, column bases, curved sections for wells. And here's a detail that shows how standardized ancient Babylonian construction was. Brick molds across the entire region are consistent in size to within a fraction of an inch, which means bricks made in one facility can be used in any construction project anywhere in Mesopotamia, a level of standardization that wouldn't be matched in Europe until the Roman Empire 1,000 years later. Now comes the most critical and most vulnerable phase of the entire process, and it's the step where most failures occur if you don't understand the science of clay. Drying. Watch what happens to these freshly molded bricks because they look solid, but they're actually about 25% water by weight. And all that water needs to evaporate slowly and evenly, or the brick will crack, warp, or crumble into dust. The bricks are being left exactly where they were molded for about 4 hours, just long enough for the surface to firm up enough that they can be handled without deforming, and workers wearing wet cloth wrapped around their hands to keep the bricks from sticking to their skin are carefully standing each brick on edge, tilting it at a slight angle to allow air circulation on all surfaces. The drying field is arranged with careful attention to sun exposure. Fresh bricks go in areas with light shade, partially dried bricks graduate to partial sun, and only bricks that have dried for at least 3 days are moved into full direct sunlight. And this gradual progression prevents the surface from drying too fast while the interior is still wet, which is exactly the condition that causes catastrophic cracking. The master brickmaker is walking through the drying field constantly, checking bricks at different stages, looking for the telltale signs of problems. Cracks forming at corners mean the clay is drying too fast. Sagging shapes mean the clay was too wet when molded. White patches on the surface mean salt is leaching out, and this batch of clay needs more washing. Drying time depends entirely on weather. In the peak of Mesopotamian summer, when temperatures exceed 120 degrees Fahrenheit and humidity is almost zero, bricks can be fully dry in 4 days, but during cooler or more humid periods, they might need 2 weeks. And rushing this process, trying to move bricks before they're ready, destroys more bricks than any other single cause of failure in the entire operation. Here's something that surprises most people about ancient Babylonian bricks. The vast majority of them are never fired in a kiln at all. They're sun-dried bricks, what we call adobe today, and they work perfectly well for most construction purposes in Mesopotamia's dry climate, where annual rainfall is less than 6 inches, and buildings face more problems from heat than from moisture. But for important structures, for temples, for palace facades, for city walls that need to resist siege weapons, for anything that will be exposed to standing water or needs to last for centuries rather than decades, the Babylonians are using fired bricks, and the firing process reveals a level of pyrotechnology that's absolutely sophisticated for the Bronze Age. The kiln area is located downwind from the drying fields because nobody wants smoke and sparks near thousands of unfired bricks, and you're looking at massive updraft kilns built partially underground, with walls made from previously fired bricks arranged to create chambers about 12 feet square and 8 feet deep. Loading the kiln is an art in itself. Workers are stacking sun-dried bricks inside in precise arrangements that allow hot gases to circulate, leaving gaps between bricks, creating channels for airflow, and packing approximately 3,000 bricks into a single kiln load. And they're not loading randomly, they're placing the best bricks in the hottest zones and inferior bricks in cooler zones, because temperature variations inside the kiln will affect the final quality. The fuel is going in now, and this is another detail that shows how resource-intensive ancient brick production was. They're using date palm wood, dried reeds from the marshes, and in some cases, dried animal dung, all carefully arranged in a firebox at the base of the kiln, and a single firing will consume several tons of fuel, a significant expense in a region where wood is scarce and valuable. The firing begins at dawn because the workers need daylight to monitor the process, and it's not a simple matter of lighting a fire and walking away. It's a continuous operation lasting 30 to 40 hours, where experienced firemen are constantly feeding fuel, monitoring temperature by eye because they don't have thermometers, but they can judge heat by the color of the flames and the glow of the bricks visible through small inspection ports, and making constant adjustments to airflow by opening and closing vents in the kiln structure. The temperature is rising gradually through distinct phases that the Babylonians recognized by experience. First, the water smoking phase, where residual moisture turns to steam. Then, the black smoke phase, as organic matter in the clay and straw burns away. Then, the oxidizing phase, where the kiln reaches cherry red heat and the clay particles begin to vitrify, fusing together at the molecular level into a substance harder than any stone the Babylonians can quarry in their region. And finally, the peak temperature, somewhere around 1,000 degrees Celsius, held for several hours to ensure complete firing throughout every brick in the load. The skill involved in this firing is remarkable, because overfire the bricks, and they become brittle, and can even melt into deformed lumps. Underfire them, and they'll be weak and porous. And the difference between perfect firing and disaster can be just a few hours of firing time or a few degrees of temperature. So the master fireman never leaves the kiln during this critical period, sleeping in shifts, eating meals brought to him, making dozens of tiny adjustments based on subtle cues that only decades of experience can teach. When the firing is complete, they're sealing all the vents and letting the kiln cool slowly over 3 to 4 days, because rapid cooling causes thermal shock that cracks bricks just as effectively as rapid drying. And finally, when the kiln has cooled enough to touch, workers are unloading it. And this is the moment of truth, where they discover whether this firing was successful or whether they've just spent days and enormous fuel resources to produce 3,000 expensive pieces of garbage. Quality control happens at multiple stages, and it's surprisingly rigorous for an ancient manufacturing process, revealing that the Babylonians understood empirically what we now know scientifically about ceramic materials. For sun-dried bricks, inspectors are checking each batch visually for cracks, deformation, and color uniformity, then doing a simple but effective strength test, standing on the brick. And if it supports a man's weight without crumbling, it's probably strong enough for wall construction, and they're also doing a moisture test where they press their thumbs into the brick's surface, and if it leaves an impression, the brick isn't dry enough and goes back to the drying field for another week. For fired bricks, the testing is even more thorough because these expensive bricks are being used in critical applications where failure isn't acceptable. They're doing a ring test, tapping each brick with a wooden mallet and listening for a clear ringing sound that indicates complete firing with no internal cracks versus a dull thud that means the brick is under-fired or has hidden fractures. And experienced inspectors can hear differences that untrained ears can't distinguish, and they're doing a breakage test where they sacrifice one brick from each batch, breaking it in half to examine the interior color and texture, looking for a consistent reddish-orange color throughout that confirms even firing, and checking that the brick is clean and sharp rather than crumbly, which would indicate weakness. There's also a water absorption test, where they immerse a brick in water for a day, then check how much weight it's gained. And while the Babylonians don't have precision scales to measure this scientifically, they can feel the difference between a well-fired brick that absorbs minimal water and a poorly fired brick that soaks up moisture like a sponge and will eventually crumble when used in walls exposed to rain or groundwater. Now watch this next process, because it's where ordinary bricks become works of art, where the Babylonians elevate brickmaking from utilitarian construction material to decorative medium, capable of creating the famous glazed facades that will still be stunning visitors 4,000 years later when archaeologists dig them up and reconstruct them in museums. They're applying colored glazes to specially prepared bricks that will form the Ishtar Gate and the processional way. The base bricks for glazed work are fired slightly differently, to a lower temperature that leaves the surface more porous and receptive to glaze, and they've been molded with shallow relief designs, lions, dragons, bulls, flowers, geometric patterns carved into the mold so the design appears on every brick produced from that mold, ensuring consistency across thousands of pieces. The glazes are being prepared in workshops adjacent to the kilns, and they're not simple colored clays. They're sophisticated ceramic formulations requiring materials sourced from hundreds of miles away. Copper compounds for the famous Babylonian blue, antimony for yellow, iron for red and brown, and a lead-based flux that allows these minerals to melt into a glassy surface at temperatures the kilns can achieve. The glazes are mixed with water to create a slip consistency, and workers are painting them onto the relief-molded bricks with brushes made from bundled reeds, carefully filling the recessed areas with one color and leaving the raised areas in contrasting colors. And the precision required here is extraordinary because glaze colors before firing look nothing like the final result. So the painters are working entirely from experience, knowing that this ugly, gray-brown paste will fire into brilliant blue, that yellowish white will become gleaming yellow, that rust-colored mud will emerge as deep red. The glazed bricks go back into the kilns for a second firing at lower temperature, around 800 degrees Celsius, just hot enough to melt the glaze into a glass-like surface, but not so hot that it runs off the vertical surfaces or changes color unpredictably. And this second firing is even more delicate than the first because temperature control is more critical and the margins for error are smaller. And a kiln full of glazed bricks represents such enormous value in materials and labor that a failed firing is a financial disaster. The finished bricks, whether sun-dried for common use or fired for important structures or glazed for decorative facades, are being moved to storage yards where they're organized with a level of inventory control that shows the Babylonians understood logistics in ways that might surprise us. Different sizes are stacked separately. Fired bricks are kept away from sun-dried bricks to prevent confusion. Batches are marked with temporary clay tokens that identify which crew made them and when, providing traceability if problems emerge later. And there's even a primitive quality grading system where the best bricks, those with perfect dimensions and no flaws, are reserved for visible exterior faces, while slightly imperfect bricks that are still structurally sound are designated for interior work where appearance doesn't matter. And even broken or failed bricks aren't wasted. They're crushed and mixed into new clay as temper, or used as aggregate in mortar, or employed as drainage. Material and foundations, because in a resource-constrained environment where every brick represents significant labor and materials, nothing gets thrown away if it can possibly be reused. The scale of storage is impressive. A major brickmaking facility serving construction in Babylon might have 200,000 to 500,000 bricks in storage at any time, representing months of production by hundreds of workers. And this stockpiling is necessary because construction in Mesopotamia happens in seasonal pulses, concentrated in the months after the spring floods when the ground is dry enough to lay foundations, but before the summer heat becomes unbearable. So bricks are made year-round but used intensively during these building windows. Transportation to construction sites reveals another aspect of Babylonian brick logistics that's easy to overlook. These aren't light modern bricks. A single Babylonian brick weighs between 20 and 30 pounds when dry, and moving millions of them from outlying brick facilities to construction sites in the city requires a dedicated workforce of porters, donkey drivers, and boat operators. Because the most efficient way to move massive quantities of bricks in flat Mesopotamia is by water. Loading them onto reed boats that float down canals to discharge points near construction sites where they're unloaded and stacked again, and this multi-stage handling means that bricks can be moved and moved and moved again and still need to remain intact, which is why quality control during production is so critical. At the construction site, masons are receiving these bricks and finally putting them to their intended use, laying them in walls with bitumen mortar, a sticky black petroleum product that the Babylonians extract from natural seeps, and that provides a waterproof bond superior to the lime mortars used in other ancient civilizations. And they're laying bricks in patterns that have structural logic. Headers and stretchers alternating to tie the wall together, bonding courses that link inner and outer withes, and the famous Babylonian wall construction where they're building composite walls with a core of cheaper sun-dried brick faced on both sides with expensive fired brick, getting the weather resistance of fired brick where it matters, while economizing on the costly firing process for the interior that nobody will ever see. The worker who molded the brick you're looking at, one of millions, probably started his apprenticeship as a child carrying water and sand, graduated to preparing clay, eventually earned the right to mold his own bricks, and might spend his entire working life, 30 or 40 years, doing nothing but forming clay into rectangles. And yet his work, multiplied by thousands of workers across hundreds of facilities, will literally build a civilization, will create the walls that protect Babylon from invasion, the temples that connect earth to heaven, the palaces where kings make the decisions that shape history, the houses where ordinary people live their lives, the warehouses that store the grain that prevents famine, the workshops where craftsmen create art and technology, and even the great ziggurat of Marduk, the Tower of Babel itself, rising 300 feet above the Mesopotamian plain and visible for miles, constructed entirely of bricks that began as river mud, were mixed with straw shaped in wooden molds, dried under the brutal sun, sometimes fired in smoking kilns, and finally stacked into structures that will stand for millennia, surviving the fall of Babylon itself, surviving centuries of abandonment and decay, surviving grave robbers and archaeologists and modern wars, until finally excavated and studied and marveled at by people from cultures that Babylonians could never have imagined. People who will look at these ancient bricks and realize that the simple act of shaping mud into rectangles and drying them in the sun, perfected over thousands of years, refined through countless innovations too small to be recorded in history books, but accumulating into genuine expertise, enabled humans to build permanent cities, to create architecture that inspired awe, to establish civilizations that would influence every culture that came after, and all of it depending on this one fundamental technology that you're watching right now. Workers transforming the most common material on Earth, dirt, into the building blocks of civilization itself, one brick at a time, day after day, generation after generation, creating with their hands and their knowledge and their relentless labor the physical framework within which human history would unfold, proving that sometimes the most important technologies aren't the most dramatic or the most complex, but the most fundamental, the ones that take simple materials and simple processes and, through careful observation and patient refinement, transform them into tools that change everything.